terms of v and s and t. So I hope that doesn't lead you astray. Okay, now it's time to start combining equations. So here's how we're going to do it. The first thing I'm going to do is I'm going to take this fact that the position of the car and the position of the person equal each other at this time catch, and I'm going to say, okay, if I use that fact, then I know that the person and the car are the same, so I can really substitute this right here. I can use this right here. I can say, okay, well, the car equals the velocity of the person at that time. And I can say that with that, okay, I can plug this. So if that's true, let me repeat that again. So I can say that the position of the car, so S car, equals the velocity of the person at time catch. Okay, we're going to need a lot more time for this. We're going to split this up into 2 videos. Okay, and that's V person time catch, right? So then I'm going to take that equation, I'll use a different color now, that equation, this equation right here, I'm going to use that and plug that into here. So I'm going to replace the position of the car with the velocity of the person times the time catch. Okay, and this is going to be at time catch, so I'm going to replace this delta t with just time catch. So now I'm going to rewrite this equation as this. So I'm going to say that the VP, velocity of the person, oops, excuse me, that shouldn't have been equals. It should be time catch times time catch equals 1/2, and this equation we got from before with rearranging tools. You need to read that text to understand where we got that equation. All right, so acceleration of the car times t catch again, and then this is going to be squared plus 20 meters. There's a plus sign, it's not a t. I'll make the t's look a little bit more like a curved t, like a cursive t, so it's not confused with the plus. All right, great. So now what? I'm also going to use this equation right here, velocity of the car equals the velocity of the person, and I'm going to use that in here. I'm going to do this. Use this fact for here. So I'm going to replace the velocity of the car with the velocity of the person at time catch. So I'll write that down too. So we have the velocity of the person is going to equal the acceleration of the car at time catch. So times time catch. Okay, great. Wonderful. Right, now I'm going to rearrange this, okay? So again, I've done a lot of plugging in. Now I'm going to rearrange this equation to equal time equals catch because I want to plug that into here. And this all will make sense in a few minutes, believe me. So I'm going to rearrange this. The way I'm going to rearrange this is divide both sides by A. So it's going to be VP over A car equals time catch. Okay, I'm going to take this equation now. We need a different color. This equation now, I'm going to replace every time I see T catch with VP over A. So this is what it's going to look like now. So, all right now, so again, so it's going to be VP times, now we've replaced T catch with a VP over a car. VP over a car equals 1/2 car times, oh, now we replace this right here, VP over a car, right? Squared plus 20 meters. Right. Running out of space. Next step, we're going to rearrange this and solve for VP. Believe me, it will work out. We're doing this all because we have these values given to us. So you'll see that they will all work out very quickly here. Okay, so again, I just replaced all of t catch with VP over a car. I got that by plugging this equation right here into here. All right, and this is true at t catch. They have the same velocity, and this is just an equation which we got from up over here, which is just a true statement. Okay, so now what? Now we have to use some algebra. So multiply this term by this term, you're going to get the following term. You're going to get VP squared over a car equals 1/2. Now I'm going to distribute this a car to this, and I'm going to see that if you do the algebra right, okay, I hope you're doing the algebra right, it's going to be VP squared over a car plus 20 meters. Right. So it's going to be 1/2 times this value right here. Make sure you follow that. Okay. Now to do the next step, you just need to subtract 1/2 VP squared over a car. Oh my God, we've got VP squared over a car over here. So what if we do, if we take 1/2 of something from something else, you're just going to have, so let's just say minus 1/2 VP squared over a car. Take that away from this side, and then take 1/2 VP squared over a car. You're going to get 1/2 VP squared over a car. Okay, so subtract, again, you're taking just half of this quantity, and that's the same quantity as this over here. So you're going to get just half of the quantity remaining, equals 20 meters. Oh, now it's starting to get a little bit more simple. Okay, now to solve for VP by itself. You're going to multiply by 2 on both sides because it's 1/2 times this. So it's going to be 2 times 2. And we're also going to need to multiply by a to get rid of the a on this side. So it's going to be times a car. I'm doing this all in one step, I apologize. And we're going to need to get rid of the square root. So we're going to square root this side, and this will all equal VP. Oh man, we found out. So we know what the acceleration of the car is, the streetcar. 2 is a number, 20 is a number, and so we can solve for VP. So for the velocity of the person turns out to be 6 meters, 6.0 meters per second. Okay, that's important. That's actually question number 2. But to solve for question number 1, we're going to take this value and we're going to, again, plug it in to here. Because we know now we know the velocity of the person. It's going to be the same as the velocity of the car, by the way. And we know what the acceleration of the car is. We can find out what the time is it took for them to catch each other. Or the time it took for the person to catch the car. Okay, so plug this in here. You're going to get, for a t catch, I'll use that other color. Spring, it's called. Okay, so for t catch, if you plug this in, and remember what the acceleration of the car is 0.9 meters per second squared. So for t catch, you're going to get, what is it? Oh, you're going to get 6.7 seconds. Okay, so t catch is 6.7 seconds. This is the velocity of the person. That's the second question. The last question is, how far have they traveled? Well, we have an equation to solve for that. What's an equation to solve for that? How far the person has traveled? We can use this equation right here. So we can say, all right, the position of the person equals the velocity of the person. Just use person still. At t catch times t catch. Okay, so t catch is this. So just plug that in, and VP Well, that's that. We'll just plug that in. These two multiply by each other. That'll give you the final position of the person. So it'll be rounded. It'll be 40. I'll use 2 sig figs. 40 meters. That's how far they've traveled. Wow. And that's the point at which they catch. That's S catch, too. So that's S catch. Great. Wow. That was a tough problem. And by the way, that's a pretty fast velocity, 6 meters per second. Right. So what do you need to know about this? Well, not much. You just need to be able to follow where I went and plug things in and rearrange things algebraically. This is basically like a little algebra class. If you figured out what I was doing and why I was doing it, you could take a look back over here, maybe follow through the steps that we took here. You're on a really good track if you can figure out the rationale behind why I took the steps that I took. This graph right here is important. This graph up here, that's good to be able to visualize this, that the person who is accelerating has a position versus time graph that looks like this. It's curved upward, like kind of like this curved line. That means that their velocity is changing at this rate. And a person with a constant velocity has just got a straight line here. Okay, so that's really the only thing you need to know, this graph, and you just need to be able to follow my reasoning through here. You don't even need to make that reasoning yourself. Don't try to memorize all of these steps that I just went through right here. Believe me, it'll give you a headache, and it won't be worth it, and you'll get confused. Just follow what I did and be able to rearrange things like I did, and you'll be in good shape. Okay? Yeah. This was a tough problem. I'll say again, tough problem. I hope this made sense. Please let me know if you have any questions about this. Okay.